Hey guys, this is my last video dealing with astronomy. My other two videos, which I've now labeled Into the Universe Part 1 and Part 2, this is Into the Universe Part 3. And this is my last video dealing with this topic. In my previous video, I was talking about the Horse Nebula. And some of the information on there, I just want to dive into a little bit deeper. And one of the things I told you was not exactly 100% accurate. It's accurate, but not 100%. I want to make sure that you guys get the best information that I can possibly give. And that has to do with the size and light years across. When I finished the part two video, I did some research to make sure that I was telling you the right information, and the vast majority of it was right on. However, the size of it, is not thousands or millions of light years across, which I didn't say. I just said many. I said maybe many, 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 but it's actually about three. When I got off my other or finished making my other video, looked at some information here, and I just look a little bit actually. The Horse Nebula is only about 2 to 3 light years across. Now that is still huge. Again, the speed of light is moving at 186,000 miles per second. So doing 186,000 times 60, I mean, look how big that number is, and that's only 1 minute. And then times that number by 60, now you get that in an hour. And then times that number by 24, now you get 1 day. And then times that number by 365, now you get 1 year. Now you kind of get the idea of the magnitude of that number. So that cloud is still really, really big. The cloud itself is located in the constellation of Orion, and it is basically formed by a descending cloud formation that happened from a huge, huge supernova explosion. That huge supernova explosion created a lot of the stars that you see near the Orion constellation. And just some more information, like right there, it tells you. And other parts on Wikipedia is also saying that actual Horse Nebula is making low mass stars as we speak. So that nebula is actually forming stars right now. Just like I said, more than likely gravity's pulling that stuff in, or that matter in, and creating stars. And it is. Another place I saw, I think it said about 5 million years from now, they believe that that whole area, all that gas will be sucked up and gone. So check out the information if you're interested. It's a lot on there about the Horse Nebula and the constellation Orion and how it was formed. Again, right here it says the Horse Nebula and the Flame Nebula are part of one massive region called the Orion B molecular cloud. And again, that cloud or that area kind of is being formed by similar events. Okay, so let me go on now to the actual reason I want to make this last video, and that's really talking about this image you see right here. Stars, many of the times, not all the time, are made from pre-existing stars that die. They release their gas, and a lot of them release their gas by well, really two ways. Either whether you're a super red giant or just a red giant. And in this image, we see they don't use the terminology super red or red. They use massive star and sun-like star. So this would be a red giant, and this would be a super red giant. So they both come from the same source, a star-forming nebula. And again, a lot of nebulas are created from, you see how this is created from other stars that have died. And they just kind of regenerate themselves. Now, that is not 100% all the time a law that it happens like that. A lot of times it could just be leftover debris from the original Big Bang that finally coalesces into a region that's able to be pulled into a star. So we have different scenarios for this. But anyway, if you're a red giant, remember you're going to live longer in comparison to a super red giant, which doesn't live near as long. These guys use up all their energy very quick, and quick in returns in terms of astronomical time. They use up their energy very quick. So you have a sun-like star, which is our sun. Our sun would do this. he'll get larger. And as he gets larger, what's going on is the core can't hold on to the matter anymore as hydrogen is converted into helium and dissipates. It kind of fluctuates away. The core can't hold on to it because as it's getting bigger and bigger and bigger, as the hydrogens turn into helium, it's getting from the core, it's expanding out. It's getting further and further from the core, and eventually it's bleh. So after it becomes a red giant, it's called a planetary nebula. And what's left over is a white dwarf, and you see that right there, a white dwarf. And that will eventually just cool off, theoretically, and become a black dwarf. And black dwarfs are theoretical at this time. All right? Some of the sources I've read said we haven't went through enough time. 14 billion years is not enough time to allow these guys to cool off to where they're black dwarfs. But a black dwarf is theoretical. At least that's what I've read, and that's from what I have researched on, and I'm pretty sure I'm confident that's right on that. Okay, a supermassive star, total different lifespan, total different. What's going to happen here is these guys are going to become massive in size, burn their energy very quickly, and they go into something that's a super red giant, and then it becomes a supernova. And when a supernova is different, supernova is what gives us the ingredients for life. The elements that are in you basically come from a supernova explosion. I believe I said that in my second video. Anyway, this creates the new matter that is needed for life. And a lot of these are, have happened over the course of the past 14 billion years, which gives us hope that life is other places in the universe. Now, when a supernova explodes, you're going to have, you see three different things here, three different branches. A lot of the material is left over and becomes another star layer down the road. Depending on the size of it, it designates where these two go. If it's like a class 3, I forget the different classes, but the bigger your class, the more chance that you go into a black hole. Basically, gravity causes a sinking in effect of the matter, and you have a black hole forming. Or you have an explosion, and what's left over is a neutron star. Now, remember we talked about neutron stars earlier in my previous videos, just the mass of it, just a spoonful of it, how big, or not how big, but how heavy the material would be. But that's the leftover remnant of a super red giant. So you have three different possibilities there with regards to how this is going to interact or how it's going to finalize. And one is definitely going to happen. You're going to have the material being left over for other stars to be born. And then these two are dependent upon its size, basically the class of it, whether it's a class 1 or class 2 or class 3. I believe it might even go higher than that. All right, so these are the different possibilities in regards to the life cycle of a star. Let me go back real quick, make sure I didn't miss anything. This is just showing star formation. Nebula is pulling in material. You see it circulating into a disk. It's kind of all spread out here. And then gravity circulates it into a disk, and eventually you have a star being born. That's called a protostar. And you have the planets going around the protostar. If this was a supernova, this would have the ingredients possibly for life, the elements that are in you. And whatever planet traps those elements might have a possibility of life later on down the road. And yeah, this is me just talking again in this slide about supernova versus a planetary nebula, which I feel I covered pretty good throughout this video. A supernova explosion, that's SNs, approximately 1 per second in our universe. Remember me telling you that it happens pretty frequently. That's why we are hopeful that it's life out there, because 1 per second in this video, think how many have went off. And again, they have the key ingredients for life. In our galaxy, only 2 per century. So a small number in comparison to the universe. Our galaxy, again, is only one of billions out there. All right, so I hope you found this series informative and that you can use it as you prepare for your SOL. If you didn't get enough of this, like you're like, hey, I'm still confused, please watch it again. Astronomy is going to be a big part of your SOL, and I want you to be successful. So I look forward to seeing you guys, and thank you for watching. Goodbye.